We are back, and this time I would request Mr. Gulam Husain to start his part of the this session. And he, as everybody knows, is an AI ML expert and has his own company, but he has been working with large corporates and even small medium enterprises, such as some of the simple things that he's done with me. So welcome back, Gulam. Please start your comments on Dr. Alok Bajpai's talk, and also further technical and other information that you wish to provide to our viewers. Thank you.
Sure, thank you. And just a bit of a disclaimer that I'm not an expert. I mean, yeah, so yeah, on the path to gain some expertise by virtue of doing some projects in that. Like we started more as an application development consultancy, but yeah, given this opportunity and where world is headed, but definitely this has been my keen research interest, and I tried to pursue PhD in the, which is suspended right now, hanging in the middle. But yeah, so that's
Will come in
I
system too.
exactly. So I just thought, yeah, I will clarify that. I mean, expert is like Alok sir is expert, so
Yeah, nobody is.
So probably, yeah, we'll get there. I mean, yeah, but yeah. So thank you for that enlightening talk, Alok sir, and a lot of things came out of that for me at least. It will require a full-fledged session, I guess, to go through, unpack everything, but we'll not do that in the interest of time and to remain focused on what we set out to do in the beginning, as the mandate of the talk was. However, so I would like to start with your question. Yeah, why the hell are we even doing this? Yes. So because it's a very interesting question, and it's a multi-layered in my view. So this was addressed by Iqtedar Bhai as well. As to one is like we want to automate as much as possible. Like it's the next layer of automation. We have run out of things that we can automate, like dumb things. Now we are moving up the value chain. So that's very sensible. That's right thing. And yeah, so this automation business is started from the industrial revolution, right? So we started automation things which are repeatable, low in the value chain, which can be easily automated, and we can have more output by employing less and less people, because no one wants to deal with people, especially in this capitalist economy. Yeah, so if you can get maximum done out of minimum resources, that's what you are after, right? And then machines don't complain about overtime, and they don't ask for paid time out, and and they don't get ill, sick and stuff like that. So next layer of automation is the knowledge economy. Yeah, so basically what we could automate is that, okay, everything other than the decision making, right? So everything other than the decision making in a plant, in a factory, in an office setting, everywhere, that could be automated as we speak now, right? That can be automated. Now next frontier is that how can we automate this decision making? Yeah, so by looking at that scan, I mean, whether our program can tell whether this requires further investigation in terms of the tumor that is there in patient's mind or not, right? Yeah, so if a machine can do that, then probably yeah. So that's because radiologists cost a lot, pathologists cost a lot. So yeah, so that's the next layer of automation. That's just one. That's very business oriented approach, and that makes perfect sense from business. There's another layer to it in my view, is that and there's a book written by Gary Marcus. Gary Marcus is one of the AI pioneers, Klug. So basically what he's arguing is that, as you alluded to quite beautifully, is that primary function for the past, I don't know, 100 and 1,000 years, millions of years of this evolution, the primary function of brain has been to survive, yeah, that is why system one thinking is so strong, right? So it's all about survival, just somehow live to the next day, So that has been the primary function. So from that function, evolution has designed this brain bottom up. So from here onwards, what we are trying to do, we're talking about domination, the automation, controlling the resources. So for that, this brain is not very well suited, because this was not the original intent,
Yes.
Yeah. So original intent was just to survive somehow, right? That's where, and we somehow went on tangent and are here talking about this on a Zoom call. But our brethren species, sister species, they are still in that mode, right? They're worried about a goat or a leopard or a snake. They're more about surviving the next, somehow finding the next meal and surviving, right? Keep doing that. So that's what this brain is well suited for. And if you try to do other things, then they find this is really, really high cost and ill suited, So that is why some people want to have a machine that can actually do that bit of work, where we can dominate over the resources. We can take a strategic decision which can help them dominate over the resources and things like that. And that's where ethical AI and all that comes into play, right? Yeah. Whether it's even a good idea for like machines to take decisions on our behalf. Yeah. So yeah, it's a very philosophical and very strategically important question in my view. But you raise a very important, casually you raise this very important question as to why the hell are we even doing this, So these are the things that come to my mind. Yeah. Now coming over to this neurosymbolic. So yes, brain is extremely complex, and evolution has actually done great deal of work in terms of how can it work on its own and survive and keep learning and keep getting better. Yeah. In that sense, we are nowhere near that. Like the machine intelligence is nowhere near that. We are at a stage where we have been able to successfully prove, in my view, that machines do learn. They can learn. From the data, they can learn and update their algorithm. So that much we have been able to prove. And it's we have just scratched the surface, in my view.
Yes.
Now, in that respect, I would say that again, we briefly touched upon that in our last lecture, that there are two main strands. One is symbolic and one is connectionist, like machine learning. So symbolic view is that we have to have a representation of the world,
Yes.
Yeah. And we should be able to apply reasoning on top of that representation to derive at a particular, conclusion. So that's one worldview of how AI should proceed. So which is called symbolic, And I think it's very important to note here that entire programming, coding is nothing but symbol manipulation, right? So this object-oriented programming is symbolic. So we try to simulate the real world. We create the objects like account, finance, whatever. Yeah. So this has delivered us great deal of efficiency. Yeah. So that goes without saying, and that's something that goes in favor of the symbolic argument, in my view. However, at the same time, there is a very strong view that you just can't represent the entire world. World is so complex. Yeah. So you can't manually develop a representation of everything that is in the world and all the rules that run the world. Is just too onerous a task. That's the other side of the argument. So what that argument is, that we just can't do that manually. We have to rely on some statistical methods to actually learn from the experience, learn from the data, good data and bad data. And slowly there will be an emergent time where this learned network will be able to perform as good as this manually created symbolic representation. That is their argument. However, it is becoming increasingly clear that truth lies somewhere in the middle. They are going their own way, and then this very clear that this approach also works in some scenarios and doesn't work in some other scenario, and vice versa for this. Yeah. So now, leveraging best of the both worlds, what researchers have argued that there has to be an approach which takes bits of this, strengths of symbolic approach as well as the strengths of machine learning approach, and try to come up with a new approach for AI, which is pretty much what the neurosymbolic AI is all about. Yeah. So we do learning as well as we do computation, reasoning, both. Problem is that they both don't see eye to eye. They are at the different axes, So systems that do learning quite well So they don't do reasoning that well, and vice versa. Yeah. So this is the challenge that we are, I think, currently dealing with. So I have put together just one diagram, the simplest diagram, I guess, in the history of my learning presentation, just very simple, X and Y axis for you. So I can probably share that. And then I've put together 2-3 slides just to remain on the topic. If I may, I can share my screen and show it to you guys, and then we can go through that, and then we can probably discuss other
please
things.
do. Thank you.
Yeah. So I'll just share my screen quickly. Can everyone see my screen?
Yes, thanks.
Cool. So yeah, so I just put together these 5 slides quickly before the meeting, so that so that it acts as a note for my talk, basically.
Wonderful.
That's the
Thank
idea.
you.
Yeah. So this is the diagram I was talking about. One second, I'll just minimize this and put this widget somewhere else, so that doesn't distract you guys. Maybe here. Yeah. So can everyone see this?
Yes, thanks.
Yes. So as you can see, what I have said is basically this is not working really well here. We'll do it here. Yeah. So this learning is on x-axis I have put. Yeah. And reasoning is on the y-axis. Yeah. So symbolic AI lies here, where we have less of the learning and pattern recognition, less of correlation, but high on the reasoning side. Yeah. Machine learning is here. So which does really well on the learning side, but it doesn't do quite well on the reasoning side. Yeah. So what I'm proposing here is that neurosymbolic logic, whatever architecture it may eventually look like, that lies somewhere here, which employs both reasoning as well as learning at their extreme. Yeah. That makes sense?
Sure.
Yeah. Now there are the symbolic guys, Gary Marcus being one of them. They say that we will need a system which has a lot of, learning, a lot of symbolic, and not that much maybe. So they prioritize this representation over the learning capability. And then there are other guys, deep learning Janta, that lies somewhere here. So still there is a lot of fight in the academic circle as to which approach should be, and there are a lot of experiments going on.
This would be the emergent thing then.
Yes,
learning
this is
and goes on to symbolic and all that. Yeah.
Exactly. These are the emergent things. Yeah.
Yes.
Yeah.
That's what brain does, because brain also does metaphors about metaphors, and as a emerging consciousness it is. Yeah.
Exactly. Yeah. So then in the next slide, what I have done is, again, just to summarize, so why we are doing what we are doing here in Neurosymbolic AI. So machine learning, as I said, it's really good at correlation. Yeah, that's the whole idea of that statistical approach of correlation, right? However, it doesn't, it's not able to establish any causation. So that's one shortcoming. We'll come to that later. Then this is more aligned to what Alok sir was talking about, system 1. Yeah. So it can't reason, it can't provide attention. It can give you like a split second results once the model is mature. Yeah. It's extremely data hungry. It cannot. So that's one of the benefits of machine learning, is that it can deal with the ambiguity. Whereas in symbolic, when you develop a logical rules engine or logical tree or something, so if you make one mistake somewhere, so entire logic will fail. So it can't deal with ambiguity. Whereas in machine learning, the beauty is that it can deal with ambiguity. Yeah, there's no reasoning capability. This is very important in my view. There's no compositionality. Basically, so in machine learning, what people are struggling with is that you can't, with the smaller parts, you can't compose and build a bigger model. So it's a lot of research is happening. Decodable neural networks are changing that. But at bottom line is that as it stands now, the machine learning machine learning models are just one unit. You can't just keep building more complex model with using smaller models at this stage. So that's a major drawback. So whereas if you want to simulate the brain, so brain is highly compositional. So from one concept or a couple of concepts, it will keep generating more complex concept. That idea of abstraction is there, which is missing in machine learning models. And it's a totally black box. There's no explainability, how that neural networks arrived at a particular decision. Why it declined the credit card application to a particular applicant. So there is very limited explainability. Whereas on the other side, symbolic, so there is a knowledge representation and logic. So basically you can see through that, right? You can completely analyze why this decision was made, because you will have full control of the smaller part of the model, right? And then it is more aligned to the system too. So it requires attention. You carve it out manually. It takes time, but then it will give you better results for the strategic discussions. So that's more aligned to system 2. It's a modular. It's very compositional. That's one of the benefits of symbolic. Yeah. So basically, you can, with the smaller parts, you can keep building the more complex parts. That's one of the big advantages of symbolic approaches. It has better explainability, because at the logic level, you would be designing that, then you will be able to explain any decision, or you will be able to test it out. If it is giving you wrong decisions over and over again, then you have somewhere along the line, you have put the wrong rules in and wrong logic. Yeah. And you can actually dissect it across the, and see through the logic and see through and correct it, and it can explain you better as to why it's giving you decisions it is giving. But unfortunately, there is no tolerance for ambiguity. So so crux here is that there are good, strong and weak points of both approaches. And unfortunately, because they were being worked upon in silos, so AI community was not getting the results that they intend to and need to get to the next level. So then they are merging that into one field as to Neurosymbolic AI. So because there are practical benefits in combining both the approaches, and neural networks, the benefit of neural networks as a base is that it gives you the symbols automatically in real time. That's one of the things that Alok sir touched upon as well. That in brain, the beauty is that you are getting those symbols, those information in real time. But in symbolic logic, that's one of the challenges. So with neural network, because neural network architecture is such that it will get the data in real time, and then within that you will implement your symbolic approach so that those symbols you are getting in real time, right? And then that will be analyzed by your logic internally. Yeah. So basically, then it helps the form of representation and understanding of the problem domain. So that's another thing I will so touch upon that. As to causation, basically there is another thought here propagated and I think spearheaded by Julia Pearl. Like Julia Pearl is so he was one of the original researchers whose research group wrote the first spam filter. So the spam filter that works in our emails, so that owes a lot to Julia Pearl and his team. So he comes from that probabilistic model background, and he argues that there is a limit to learning from data. So data can teach you correlation, but data can never tell you about the causation. So for example, like a rooster makes noise, crows in the morning, and sun rises. So data, if you record those findings over a period of time, your machine learning model will be able to tell you that yes, there is a correlation. So sun rises at 5:30, and there is about time that rooster makes noise. Yeah. However, machine learning cannot establish what is causing what, whether rooster is causing sun to rise or other way around. So for that to understand, for your AI system to derive that knowledge, you need to look beyond the data. You need to actually have a causal model of the process that is generating this data itself. So that's another layer of research that is happening, causal inference on top of Neurosymbolic AI. So together, all these approaches have their own strengths and weaknesses. However, where we are all headed is that so these different research approaches are more integrated now and working together. So next point that I am outlining here is that ontologies are playing a major role in that. Ontology is nothing but actual formal representation of the world, formal representation of whatever data that you are collecting. So that will underpin every reasoning, automated reasoning going forward. And then neurosymbolic approach will be highly modular, and of course, we have long way to go, but will simulate the brain. It will be more aligned with how brain works, right? So that I have put together here as, again, to give credit where it's due. I wish this was my diagram. This is not my diagram. This is from Novable magazine, but it explains whatever I explain in these 3 slides very nicely in one diagram. So there's a high level neurosymbolic architecture. Yeah. So basically, as you see, the symbolic AI that I was talking about, so that's nothing but knowledge base, and then you have inference engine, right? So you manually create a knowledge base, which is highly time consuming and very complex. Then once you have that knowledge base, you write some rules engine, and then someone asks question, yeah, and then based upon the knowledge base and rules engine, your symbolic AI gives you answer. Yeah, so it's very simple. However, again, as you can see, it's not learning. There's no networks here. There's no network update. There's no backpropagation. Nothing. On the other hand, where we have deep neural network or neural network, so you have input, right? And you have your network, and depending on the answer you get, the accuracy of answer you get, you keep updating the weights here to the extent that at a given point in time, it starts giving you quite reasonable level of accuracy in its answering. So this is neural networks. Both have their strengths and weaknesses. What researchers are arguing is that we merge them into one. So yeah, so basically you have, so as an input, you have neural networks. The neural networks interacts with the knowledge base. Yeah. And then knowledge base then goes into the inference engine where rules are updated, and everywhere there are intelligent feedback mechanism as to whether rule base needs to be updated. That gets updated with the minimal intervention. Knowledge base needs to get updated. That's where ontologies comes into play. So they are formal AI representation of the knowledge, and they can be made quite interoperable and automated. So you have both, best of both the worlds. You have neural networks as well as you have symbolic AI. So you have input where the data is getting collected, knowledge base is getting updated, your neural network is getting updated. Then you have someone ask a question to this AI engine, whether I should invest in this company or not, whether I should do this or some strategic question. Then it gets converted into symbolic query and knowledge base both then go to inference engine, and depending upon the output from the neural networks as well as reasoning, you get an answer. So that's what Neuro-Symbolic AI is proposing as a next step. Now, it's all not theoretical. Yeah. So especially in the self-driving car space, IBM is doing a lot of research in that space. So for example, the problem here is that for any neural network to be effective, it has to learn from the bad examples, more from bad examples than from good examples. So imagine if you are teaching a car as to not to hit a pedestrian, right? In many scenarios. So this is a luxury that you can't afford. You can't just test this out, right? By car to hit the pedestrian. So of course it has to be done on the simulator. Yeah. So what Neurosymbolic AI does is that it creates a representation of that actual crash, and that reduces the amount of data that model needs to train itself quite considerably, and which is what you need for in such a mission critical, because otherwise there are infinite probabilities in which you have to test your model out if you just had to use only neural networks. Yeah. So symbolic AI has given some really good encouraging results in that space. So this is just one of the examples, but yeah, I just thought I will mention here. So these are the things where symbolic AI is being very actively used right now, and a lot of people are saying that it's a next phase of AI research, next stage.
Wonderful.
Great
learning, man. Please, can you email me these slides? I can use it for teaching.
Yeah, of course. It's just 4 slides. I was really
with credit to you. No, one very important thing which you pointed out very lucidly. It's so important. I think this is the most important part of today's session. Forget what I have said and forget. One, that the brain, see, I think neurosymbolic and machine learning are approaching brain from two ends.
Yeah.
Brain wants to remove ambiguity.
Yeah.
It wants certainty.
Exactly.
But in a world full of complexity, it is always uncertain.
Exactly.
Not possible.
That's the biggest challenge. Yeah.
So brain is taking data, putting some causal models to it, and trying to understand which may not be the most precise decision.
Exactly.
So if neurosymbolic and machine learning unite someday on some platform, that probably will be the next evolutionary step, as you said.
Exactly. So that's what. So researchers are very hopeful about, and that's I think is the next phase. Yeah. So as you would appreciate, there's so much to unpack, And for me, it was really challenging not to delve into any equations or any technical aspects. So I was just, I thought maybe I'll just put together very high level, and
wonderful.
Yeah.
So
So
that maps, sir.
Yeah,
Both the talks
wonderful.
are mapped totally now.
Just to summarize what Dr. Alok Bajpai has said, that yes, it's a mixture of the two things. And then the question to Mr. Gulam Husain, and that is that, the graph you showed, do you think the X that we are hoping for, is it going to be at 50-50 of the neuro and symbolic, or
no, that's a very good question. That requires a lot of empirical studies.
Yes.
And there's so many things that are happening in that space, like what activation function should we use, whether your symbolic processing, reasoning should be within neural networks, or neural networks should be within reasoning. I mean, so there's so many combinations but you are right. I mean, this is a very complex domain. So much research is happening as to how much, and there are so many different points of view, is how much representation should play a role in this, or how much connectionism should play a role. So that balance and mix, I mean, it's really difficult for someone like, anyone to discuss like that and come up with an answer. It requires a lot of empirical study, in my view.
True.
Which is undergoing right now.
Thanks. So now coming back to Dr. Alok Bajpai. Alok, do you think that when we are talking about modular things, the so-called human positive principles, which have been traditionally portrayed as a human instinct, that you should not hurt the other person and look after everyone, and so there are certain principles that may be termed as human principles, and they form a part of all the doctrines, whether it's religious or socio-economic scenarios, communism, whatever it is.
I'm trying to map things like Gita and Gandhi and Buddha in a almost reverse engineering fashion to neuroscience we know. And some things are emerging right now.
Wonderful.
And maybe someday we'll talk and I'll tell you what exactly it is.
Oh, that'll be wonderful.
Because then people can, I mean, I'm not saying it's all, but whatever the points are, can incite other people to do it. See, the things which we talk in religion or political systems and all are all biased. They are all explanations of world from a certain lens. Because human brain has everything, right from love to hatred, from lust to asceticism. It has a lot of contradictory probabilities existing all the time. A rapist can become a saint, and a saint can become a rapist. Same person. we have examples in history.
Ample examples. Yes.
How does it happen? It happens because it is a probability set which is being pushed to the conscious mind, on which decision making is done. That is what all neurosymbolic logic is all about. See, when human beings explainability, we don't know, because it works, because we can make some sense, it doesn't mean we understand it. Right now we don't understand. The causality which we talk about is a post hoc thing. So like Freud used to say, we are not rational beings, we are rationalizing beings.
Wonderful.
We'll do something. So our causal inferences and models come as a feedback in our mind. While doing, we don't know why we are doing it. So there is always huge possibilities. Huge possibilities. That I would never like to be snatched from my mind. Rest of it, robo can help me. It can book my tickets. It can carry me to anywhere. But final, it has to remain here. But brain is also evolving with all this. You think after 1 hour, our brains have become more intelligent.
Yeah, we learned a lot. Yeah, we learned more.
We learned a lot actually. So we learned more through bounds. Sir, but I would request one thing.
Yeah.
Your audience don't ask questions.
Yes, that's why I raised it.
Yeah,
we don't want appreciation. Who is the boss here? Nobody. If they ask questions, otherwise we'll be happy bouncing. So that is not a good way to do it.
Feedback or something like that,
Some questions
as to what they liked, what they didn't like, and accordingly we can align our talk, Yeah, so
see, otherwise we'll get bored. What do we talk after this?
Yes, agreed. There are two aspects to this. I've mentioned this to a lot of people who the problem these days is that people are too busy with their WhatsApps and other platforms. So
you can ask on WhatsApp. What is the big deal?
Yeah.
You give my number to them.
They should come back
you can ask
to us.
directly.
They don't. The problem is that even if it is in short, lately I've been doing, for 1 hour programming, four sessions and so on, releases parts 1 to 4 and so on, which will be done with this one as well. And I always request the audience to come back with their questions, comments, and whatever critiques that they have. But nobody comes back. Now,
tell them something, sir. Tell them after Gulam's talk today, see where we are going. If you don't come back with questions, you'll be left behind in evolutionary process. and the only people to understand their brain and reasoning will be the people who will keep aligned with all this. Rest of will again live like...
It's a very, very good point, Alok.
My biggest worry is that
I
Iqtedar's audience
for our audience. Maybe Gulam has a better machine language.
No, he's saying something. He's saying something.
To say that.
Gulam.
My biggest worry is that Iqtedar's audience may be one of those that are really happy being left behind, so they won't mind.
That is preserved. Somebody has to be preserved in face of all this.
Exactly.
Well, that's it. That's it. You said it. I don't think you want to demean our audience, and plenty of
maybe they are happier than
us. Where people come and talk to me. Look, that was good, but they don't have time in these days, and so on. They don't have time to respond back, and
so that is why we are developing AI, so that people have a lot of time.
Yeah, exactly.
Sawal ye ki when people will be out of job, somebody asked me in a talk, what will happen with AI? Jobs will there. I said, man was not born to work like an idiot. He was born to enjoy painting, philosophy, this, that, music. Let them do that. They will have a lot of time.
Exactly.
That's wonderful. Thank you, gentlemen. I have 1 minute left.
Thanks very much.
Thank you so much. I learned a lot from Alok sir today.
Gulam bhai, apna slides bhej dena yaar, please.
I will share it immediately. No worries. Yeah, of course. All good.
And I'm sure this will come up someday as the best slides.
Okay. Amazing. Thank you so much. Thanks a lot.
Thanks for take care. Bye.
Thank you, gentlemen, and thank you to the audience. And do come back to us, as Dr. Alok Bajpai has mentioned, that if you don't come back, you get left behind.